So in the last video we saw how that potential energy is getting converted into kinetic energy. Now we are going to see the different forms of energy which is present around us. So according to this thing, we have got around 12 different kinds of energy. These are just some which are listed down. They are much more than this, but these are the one which are being studied up till now. So by or will be studied by us in a very short manner because we don't have in detail these energy forms. So we have over here one by one the heat energy, the solar energy, heat energy, light energy, chemical energy, hydro energy, electrical energy, nuclear energy, geothermal energy, wind energy, sound energy, magnetic energy, and mechanical energy. So we see these different kinds of energy one by one in a very short manner. So the first thing what we see is solar energy. The first one is solar energy. Now this is, we can say, the energy from the sun. So here the energy radiated out by the sun is called as solar energy. Now solar energy, we cannot use it directly. Unfortunately, we are not able to use it directly as a form of energy. We need to convert it into some form or in a way that we are not able to directly perform work because it is too diffused and is not available uniformly. You can see very well that sometimes it is cloudy, sometimes it is too sunny, sometimes it is in the winter season it's too dark, so we are not able to, in some places there are 6 months of night and 6 months of day, and sometimes the number of hours of daytime is much more and night is less, and the night is more and day is less. So yeah, there's a continuous changes which is going to take place in the way the sun appears to us, and due to this reason we cannot have a directly we can say that performing work through the sun. So solar energy is not directly used up for doing some work. However, there are certain devices which we have made which will work directly by the sun. These examples are solar panels, the solar furnaces, and solar cells, etc. have been invented to make use of solar energy. So yes, we have been trying to utilize the solar energy to the maximum, and nowadays it is much more important because we can see that the fossil fuels which we are using in a normal manner for thermal power plants and all is getting deteriorated day by day. It is getting to get extinct, and due to this it becomes much more costlier to generate energy. So if we have got the solar energy as one of the main sources to do even part of the work, then it becomes very easy for us. So even if you consider that out of the whole year we are able to get only 4 to 5 months of good solar energy, then also it is good enough to save that much amount of power for that many number of months. So yeah, we have so many objectives or many options available. The government has given many options in places like Gujarat and all, where they want the people to have their own solar power plants. So there are many solar power plants kept in each and every houses on their terraces, and these power plants generate an energy on a regular basis which they partly use and when in the case of summer season, when they need when the generation of the electricity is much more, they can also supply back to the companies that okay, this is what they have produced, and accordingly their electric bills are cut down. So this is one of the thing which has been already practiced. So yes, we come to the different types of the methods by which the solar energy is used. First is solar panels, consist of black painted metal surfaces which absorb the sun's energy and heats water in its contact. So here they are also called as solar panels, are also known as solar geysers. So wherein there is a panel is there, and that panel has got a black paint on it. So black color, we know that it absorbs the heat very fast, and just below the black paint are the tubings of water. So there are tubings of water which is going to get heated up, the water gets heated up due to that thing, and accordingly there will be supply of good amount of hot water to the house. So this is very commonly used in hill stations. So if you next time when you go to any hill station, you'll find that most of the places on the terraces, on the rooftops, they will be having such kind of the black colored panel, which is nothing but the solar heat geyser, or we can say solar panel. The other is a solar furnace, has a parabolic mirror used to focus the sun rays on a small area so that a high temperature is achieved. Thus, by keeping water at the focus of mirror, water can be boiled to produce steam, and the steam can be used to drive the turbine of an electric generator so as to obtain the electrical energy. So here, this is something which is a small kind of solar furnace, which is nothing but a small solar, we can say solar power plant, we can say, wherein there is a small container which will be having water, and there will be parabolic kind of concaved, there will be one which will be a concave kind of mirrors which are placed. So these mirrors are going to focus, they will be such that they are going to reflect a light from the sun, and they are going to be focused on that particular black colored container what is kept over there, and the container contains water. The water what is there is going to get heated up by the solar heat, and it is going to get converted to steam, and that steam is made to flow and hit a turbine. So turbine, what happens when when this particular steam hits the turbine starts rotating. So it's rotating, and it keeps on so it keeps on rotating this way. So the rotation of the turbine is due to the impact of the steam on those particular turbines. So this is how the solar furnaces are used to generate electricity. And then there are solar cells which are used to convert the solar energy directly into electrical energy. These cells are made from the thin slices of semiconducting material. However, the efficiency of the solar cell to convert solar energy into electrical energy is very low. And that's the reason. This is something very common. You have got, most of the houses has got this thing, and that is in the form of a calculator. You will always find that the calculator, most of the calculators, you can see over here, most of the calculators have got this particular kind of panel over here. This panel over here is nothing but the solar panel. So this is the solar cell. So light falls on this particular thing and converts that light energy into electrical energy. That electric energy can run the calculator. So this particular kind of solar cell, the only thing over here is that these solar cells have got a very low efficiency. That's the reason they can be used only in very small devices, wherein the energy requirement of that particular device is very small. That's why it is used only in some calculators like this, or some watches. Even you can see, even mobile phones do not use the solar panel. So you can see that even mobile phones require much more power than what can be given by the solar cells, and that's the reason we have solar cells only in limited amount of devices which can be used with the help of solar cells. So that was about the solar energy. The solar energy, briefly we can say the solar energy is the one which is obtained from the sun, and the three kinds of good reputed, or we can say the well tested kind of equipments which can be made with the solar energy. First one is solar panel, then is solar furnace, and the third one is solar cells. The next we see is the heat energy. So the next form of energy is heat energy. So energy released on burning coal, oil, wood, gas, any kind of a fuel. So whenever you are using a fuel and that fuel is being burned, the amount of that burning of the fuel is going to create a kind of energy which is nothing but the heat energy. The steam obtained. So what they do is that they heat this particular kind of fuel, and that heating of the fuel is going to heat up the water, and the water is going to turn into steam. So that's why the steam obtained on heating water possesses heat energy, and it has the capacity to do work. In a steam engine, heat energy of the steam is used to obtain work, that is mechanical energy. Sun is also a source of heat energy. So we on earth receive heat energy directly from the sun. So yes, Apart from the heat energy received to us by burning of the fuels, we also get heat energy directly from the sun. So accordingly, we have got the heat energy which is used up, or we can convert it into different forms of energy. That's the reason the steam engine is an example of the heat energy getting converted into mechanical energy. The next one is light energy. The third one is light. Again, you can see that light energy too can be made available to us by the sun. So sun does give us the light energy also. So it is a form of energy in presence of which other objects can be seen. We know very well that we can see each other because of the light falling on us, and then it is reflected back to your eye. So because it is getting reflected to your eye, you are able to view me. If I would have been a person from which the light could pass through, then I would be invisible because I am not reflecting any light. So this is how we see that the natural source of light is the sun. The moon reflects the sunlight at night. Many sources such as the fire, burning candle, etc. also give light along with the heat energy. So yeah, we get light energy not only from the sun, but otherwise we also burn certain things, and when you burn certain things, we do get light. Like candle, when you burn a candle, we get the light energy too. Okay. The next one is chemical energy or the fuel. So that one is the chemical energy. So any energy what we get by burning up of any kind of a chemical material or a fuel is nothing but the chemical energy or fuel energy. We know all the petroleum products which are there, or the wood or the fossil fuels, all these are come under the category of chemical energy. So energy possessed by fossil fuels such as coal, petroleum and natural gas is called the chemical energy or fuel energy. These fuel contain chemical energy stored in them. When fuel are burned, the chemical energy changes into heat and light energy. So when these chemicals are being burned, these chemicals are going to get converted, or when they are due to the burning, the chemical energy gets converted into heat energy, as well as some amount of light will always be given out. The food that we prepare also have the chemical energy in it. Plants converted the solar energy into chemical energy for food during the process of photosynthesis. A battery has a chemical energy stored in it, and it provides electric energy which is used by a chemical reaction which takes place inside it. So yes, we can see chemical energy is also there in the food what we eat, because that food is nothing but the proteins or the starch or glucose what is being generated by the plant during photosynthesis. So whatever photosynthesis is taking place, that is nothing but the chemical energy which when we eat, we are converted in, we consume that particular energy. So that is the food we eat. Even the battery, we can say we are using a battery. What is actually happening is the chemical reaction taking place in the battery which is giving you electricity, and that's the reason uska ulta bhi wahi hota hai, that we are charging the battery, we are giving it electricity, so the chemical reaction get reversed, and when you remove the charger, again the chemical reaction will start again. So accordingly, charging, recharging or discharging takes place in a cell. The fifth one is the hydro energy. So hydro energy is the one which is due to the flowing water. So the water flowing, and when the energy which is present in the kinetic energy present in the water while flowing is converted into the form of energy. So here hydro energy is possessed by the fast moving water is called as hydro energy. The energy possessed by the fast moving water is hydro energy. This energy is used to generate electricity in hydroelectric power stations. We know very well that there are on the river sides we have dams built up. So the dams क्या करेगा? Dam जो है that will store the water, and the stored water will have potential energy. When the water is made to fall from the dam, it is going to have kinetic energy, and that kinetic energy is going to make the turbine rotate. So water falls on the turbine and the turbine rotates. As the turbine rotates, the rotation of the turbine gives you the electricity is generated by the generator. So accordingly, we see that kinetic energy of the water is being used to generate electricity in a hydroelectric power plant. So for this, water is stored in the dam built across the river high up in the hills, and the water from the dam is allowed to flow down through pipes. The kinetic energy of the fast flowing water drives the turbine of the generators to produce electrical energy. So hence the next one is electrical energy. So yeah, electrical energy is the energy possessed due to the motion of the electrons. So that is, or we can just say about the battery. So we can say when two dry bodies, we are talking about now static electricity, rubbing of the bodies. So that is right. When two dry bodies are rubbed together, they get charged due to the movement of the free electrons from one body to the other. So they possess electrical energy. In an electric cell, due to the movement of the ions from one electrode to the another electrode within the cell as a result of the chemical reaction, it becomes a source of electrical energy. So basic thing is electrical energy is produced when electrons are moving, or electrons are being moving from one point to another point. So when we are rubbing two dry surfaces, like if I take a plastic and a silk and then I rub the plastic on the silk, you will find that the electrons are going to move from the plastic to the silk. So accordingly there will be charge produced. Similarly, we will always find that whenever the cell, the battery is going to be connected, we will see due to the chemical reaction taking place in the battery, taking place in the cell, the ions are being produced and they are going to be taken to that one of the electrode, due which it passes through the circuit and comes back. So that movement of the electrons due to the chemical reaction is also the electrical energy. The next is nuclear energy. Seventh is nuclear energy. Now nuclear energy is the energy released due to the loss in mass during the process of nuclear fission or fusion. So we have a complete chapter based on this. It's the last chapter, modern physics. We have got the nuclear reactions. So nuclear fission and fusion will be studying in detail in those chapters. But in short, when I say, it is basically that whenever there is going to be a nuclear fission or fusion, fission means splitting. When the nucleus of an atom splits, there is going to be a energy released by the atom. Similarly, if I take small atoms and I fuse the atom together, combine them together to make a bigger atom, at that time also a lot of amount of energy is going to be released. So this energy released by the particular atoms or due to the fission or fusion is nothing but the nuclear energy, and it is very large amount of energy which will be released during the nuclear reaction. So nuclear reactions produce a very large amount of energy. In both these processes, the loss in mass due to gets converted into energy in accordance with the Einstein's mass energy theorem. E is equals to mc square. So this is the mass energy theorem, where E is the energy, m is the mass of the substance, and c is the speed of light. C is the speed of light, 3 into 10 raised to 8. So the energy is used in the nuclear reactors for the construction purpose to produce electrical energy, and is used in atom bombs for the destructive purpose to produce heat and form and other forms of energy, so as to destroy the enemy in a war. So yeah, we have got this, as we can see that the two sides of the coin. We have got the boons, so we also got the curses of the same thing. So nuclear energy has got the boon that the good thing is that yeah, a small amount is going to produce such a huge amount of energy that the electric energy produced will be very high. But at the same time, the same energy can also be used in destructive nature, and we have got atom bombs being generated by this particular method, which is very destructive and be very harmful for the people. So that is the nuclear energy. The next we see is geothermal energy. So the eighth one is geothermal energy. So yeah, it is nothing but geo means the earth, and thermal means the heat present in the earth. So that is nothing but the internal heat of the earth is what we are talking about. The energy released in nuclear disintegration in the interior of the earth gets stored deep inside the earth and is called as geothermal energy. So you can, what they say is that the atoms or those substances which are present deep inside the earth, and these are radioactive, or the one which are going to give rise to any kind of nuclear reaction taking place inside the surface of the earth. And these energy what is being given out, that is being stored inside the earth's surface itself. So that stored energy present in the earth's surface is called as a geothermal energy. This energy heats up the underground water to produce the natural steam. Natural steam is going to be produced. Sometimes the natural steam may burst out from the surface of the earth as hot springs. The electrical power companies may drill wells into the earth to trap the natural steam which may be used to run the turbines of generator to produce electricity. So the process is the same, running the turbine with the steam, but here the steam is produced naturally inside the earth's crust. That is because there is a underground water. The underground water which is present is going to get heated up due to the geothermal energy present in the earth, and that particular steam which is produced, so that is going to be sometimes going to into the form of hot springs in certain areas. But the companies, the power generation companies, what they can do is they can drill holes in certain areas through which the steam can come out. That coming out of steam, the steam which is coming out can be used to run the turbine. And accordingly, we can have the geothermal energy used as a form of energy to produce electricity for us. The next one is the wind energy. So wind energy, yeah, so this is nothing but the windmills what we see. So wind energy. So the wind energy is the next one. The energy possessed by the fast moving air, that is some storm, is called as a wind energy. The energy is used in driving a windmill. So we can see the wind has to be blowing in a very particular speed, only then it can be used up for driving the windmill. So accordingly, it is said that if the speed of the wind is more than 15 kilometers per hour, only then it can run a windmill in a particular manner that it can produce electricity. So that's one particular kind of a disadvantage, or we can say the limitations of using the windmills. But yes, to a certain extent, yes, wherever there is a good amount of wind blowing throughout the year, you can have, this is a very good source of energy, especially in the rural areas where giving the power supply from the power station is not so easy. They can always have open spaces, and if they have got a place where a good amount of wind is going to blow throughout the year, they can place certain kind of windmills over there which can generate electricity on a regular basis. So we can see that, and this energy is used in driving a windmill. In past, for many years in rural areas, windmills were used to pump out the underground water and to grind grains. Nowadays, large giant windmills are being used to drive the turbines of electrical generators for producing electricity. So initially they were using such kind of windmills only for pumping of water from the wells and from the groundwater from the wells, and to grind the grain. So the windmill was moving and the grain grinder would move so that the flour was being produced from the grain. So that was the initial thing, but nowadays what they use is they make the windmill run a generator, and as the generator rotates, the electricity is generated. So that's how the wind energy is being utilized. Sound energy, a vibrating body, so that is sound energy. So of course the amount of energy generated is very small, but yeah, it is a form of energy. So vibrating body possesses the sound energy. It is sensed by our ear. When the disturbance is produced by the vibrating body in the atmospheric air layers reaches our ears and produce vibration in the ear membrane, sound is heard. So yeah, how we hear the sound, that the sound is going to be, vibrations are going to be there, that vibration enter into our ear and then it hits the eardrum and we are able to listen to those particular sounds. So that is sound energy. The next is magnetic energy. Again, not too much use the magnetic energy. Now magnetic energy is anything possessed by the magnet due to its attraction to the iron filings is called as a magnetic energy, and an electromagnet has a magnetic energy. So yeah, electricity generated gives rise to an electromagnet, and that magnet what is formed is also a magnetic energy. And finally is the mechanical energy, which we already studied. That is, the one was the potential and kinetic energy. So energy, mechanical energy is possessed by the body due to a state of rest or of motion is called as mechanical energy. A body at a height, a moving body, a stretched bow, etc. are mechanical energy. So here we see that these are the different kinds of energy. So right from solar energy, heat energy, light energy, chemical, hydro, electrical, nuclear, geothermal, wind, sound, magnetic and mechanical. These are the different kinds of energy. Now this part of course very rarely asked in the examinations, not at all. In fact they never asked them list down the number of energies. No, not such kind of questions they were asked. But the main thing what is going to be asked will be the conversion of the energy from one form to another form in a particular device or in a particular kind of operation that takes place. So conversion of one form of energy into another form. So in our daily life we require energy in various forms. Since one form of energy can be converted into another form, we can obtain the energy in the required form from the other forms of energy available to us. Examples, some examples are given over here. So we now consider some more examples. So the examples which are given over here is mechanical to electrical. In case mechanical to electrical will be a generator. So a generator or dynamo converts the mechanical energy into electrical energy, whereas a motor converts the electrical energy into mechanical energy. So that is dynamo from mechanical to electrical and motor from electrical to mechanical. Now when we talk about electrical energy to heat energy, so when electrical to heat will be the iron or toaster, that is nothing but the electrical to heat, and from heat to electrical will be thermocouple. So thermocouple is the device which converts heat energy into electrical energy. Electrical to sound, now this is important. Electrical to sound will be a loudspeaker. Loudspeaker will be from electrical to sound. Whereas ulta, sound to electrical will be a microphone. Microphone will be sound to electrical. So microphone, sound to electrical. Now electrical to chemical. So electrical chemical is the charging of the battery. When the battery is charged, it is going to be from electrical to chemical. Electrical to chemical is charging of the battery. Chemical to electrical will be again discharging of the battery, or you can just say use of the battery. So use of the cell is chemical to electrical. So chemical to electrical, use of the cell. Electrical to chemical, charging of the cell. Chemical to light, burning a candle will be chemical to light. You burn a candle, light is given out, so chemical energy giving rise to light energy. Light to chemical will be photosynthesis. Light to chemical will be sun rays used for photosynthesis. It is nothing but light to chemical. Electrical to light will be bulb. Any bulb or tube light being bulb is nothing but electrical to light. Where light to electrical will be photocell. Photocell is a kind of a device which works on the light. So when light falls on it, it starts giving us energy. So that is photocell, or we can see even the solar cell. So this way, these are the different energy conversions, which is very important because they do ask such questions that give the conversions for the following, and then they will write over there. Like for example, it could be like electric iron. So you just have to say electric iron will be electrical to heat energy. Right, so the mechanical energy to electrical energy is water stored in the reservoir. The dam has a potential energy. When water flows down, a potential energy decreases and kinetic energy increases. If the falling water is made to rotate a turbine near the bottom of the dam, the kinetic energy of the water is transferred to the turbine in the form of rotational kinetic energy, due to which it rotates. The turbine rotates, the armature of the generator connected to it, and thus the kinetic energy gets transformed into electric energy in the generator. So yes, this is how the mechanical energy is getting converted into electric energy, because mechanical energy is in the form of potential energy of the water. That potential of water is going to change into kinetic energy when the water is made to flow through the dam. So when it is flowing through the pipes, so when it is allowed to flow from the pipes, it is going to give potential to kinetic. That kinetic energy of the water is going to get converted into the kinetic energy of the turbine, because the turbine starts rotating when the water hits the turbine. The rotational kinetic energy of the turbine is getting converted into the rotation kinetic energy of the generator. When the generator also rotates, and that rotation of the generator generates the electricity. So accordingly, we see how the mechanical energy is getting converted into electrical energy. Thus, an electric generator or a dynamo converts the mechanical energy into electrical energy. So this is what they have given you, and they just written the whole thing, which is over here, which is in the form of a diagram over here. They have explained the whole thing in detail over here. So not so important. So electrical to mechanical, electrical to heat we saw was the heater and oven. Heat to energy to electric energy will be thermocouple, and accordingly thermocouple will be the one in which changes the heat energy supplied or hot junction into electric energy. So wherever the hot junction is there, that is going to give rise to electricity. Electric energy to sound energy, that is the loudspeaker and the mic for the ulta part. Sound electrical will be the microphone. Electric energy to chemical energy will be charging of the battery. Chemical to electrical will be discharging of the battery. Chemical to light will be burning of a candle. Light to chemical will be the sun giving used for photosynthesis to give you production of glucose by the plants. Light energy to chemical energy is, yeah, that's done again with the help of photosynthesis, so light to chemical. Electrical to light will be glowing of the bulb will be electrical to light, and the light to electrical will be photocell or the solar cell in which we are generating electricity by the light. Heat to mechanical is the steam engine where you heat the coal and it is generating the energy to produce the to run the engine, so heat engine or the steam engine. And chemical energy to heat will be when you are burning a fossil fuel. When you burn a fuel, you are converting the chemical to heat energy. Chemical to mechanical is when petrol is being burned and it is running the whole car. So petrol is a chemical which is burned and car is run with the mechanical energy. Electrical to magnetic will be electromagnets. When you are connecting a wound wire to electricity, it is generating magnetism. So that is nothing but electromagnet. Nuclear to electrical, which will be nuclear reaction, which gives you a lot of energy due to nuclear fission, and that energy is converted into electrical energy. And finally, is mechanical to heat is when the water falls from a height, the potential energy is getting converted to kinetic energy, and when it hits, there is also going to be increase in the temperature. On striking the ground, a part of the kinetic energy water changes into heat energy, due to which the temperature of the water rises. The moving parts of the machine get heated due to friction. Thus, a part of the mechanical energy is changed into heat energy. So here we need to note certain things, that whenever mechanical energy changes to other form, it is always in the form of kinetic energy and not in the form of potential energy. So we always note that whenever any other form of energy gets converted into mechanical energy, it will be into kinetic energy. We say any kind of energy converted from potential energy, it will only be kinetic energy. So kinetic energy is the link between the mechanical energy and other forms of energy. So the stored potential energy changes into kinetic energy, and then kinetic energy changes into other forms. Degraded energy, when transformation of energy from one form to another desired form, the entire energy does not change into desired form, but a part of it changes either to some undesirable form, usually heat due to friction, or a part lost in the surroundings due to radiation, which becomes useless. This conversion of energy or to the undesirable or non-useful form is called as dissipation of energy, since this part of energy is not available for us for any productive purpose. So we call this part of energy as a degraded form of energy. So whenever, what they mean to say is that whenever the energy change takes place, at that time it is not necessary that the energy is going to convert only into that form which is useful for us. Like for example, if I light a bulb, now the bulb is going to give me light, perfectly right. But when you touch the bulb gets heated up. So when the bulb is not heated up, what does it mean? That some part of the energy of the electrical energy which has given to the bulb was converted into heat energy, which is a waste for me, or that is nothing but the degraded form of energy. So degradation, that is called as energy degradation. So when a bulb is lighted using electrical energy, a major part of its lost form of heat energy, only a small part converts into useful light energy. When a vehicle is run by using the chemical energy of its fuel, major part is wasted in the form of heat and sound energy. Only a small part of the energy is gone into mechanical energy. So here also, when we talk about the mechanical energy getting converted into the when petrol is being burned and the car moves, so we see that not only the car moves, but there is so many things which is going to take place, like the friction and all in the machine parts, which are going to be a part which is the degraded part. We don't want that energy to be used up in that form, and that's why the efficiency of that particular machine is not going to be so good. So that's why we see that there is always going to be some amount of degradation of energy taking place when there is a change of energy from one form to another form. So this was about the explanation of this part of the chapter. In the next video, we take the numericals of this chapter. There are about 23 different numericals. We'll take the thing next video.